So building off the last video where we were dealing with analog inputs and reading in analog values, I want to kind of show you how to create sound and be able to use these values here to create, certain pitches. And so a lot of Arduino kits come with some little like speaker looking things. So this is what they look like. They look similar, but if you turn them over, they look very different. So one has this like black potting on the other side, and the other one you can see there's like a bare PCB. Sometimes it's green, sometimes it's blue. But they both have polarity. They both have like a pin that is labeled as plus on the top side there. And so the difference between these two is this one here is something known as like an active buzzer, where if you just put 5 volts across it, so let's see if I can get it in. If I put it here, like this, that's the 5 volts, and there's the other one. Yeah, it makes a really terrible sound, right? It can only make one single tone, and that's because of some more active circuitry inside of it. And this is used kind of like as an alarm thing, and it's really loud and really obnoxious. This one here with the bare green underside is kind of a true speaker. It's sometimes referred to as a passive buzzer. It has a piezoelectric crystal inside of it that vibrates when you send things through at a certain frequency. Because all notes in music correspond to some certain frequency. And so what we're going to do is we're going to send a square wave, which is essentially just a series of different pulses that look like this, right? So it's pulsing between our digital values here of like on and off. So we have that. So here's our like 0 volts, and this is our 5 volts, right? And so it's going to be on part of the time, off part of the time, on part of the time, off part of the time. So it repeats like this here. And so the frequency that we're talking about is how many times per second this part repeats here. So like for an A note around the middle of the piano here, it happens at about 440 hertz, which is the units for frequency. And what that means is 440 times a second it's going between these different states here. And so what we're going to do is we're going to try to read these values and get it to play a sound through our speaker here. So what that's going to involve is adding this, just somewhere on the board. I'm going to add it just right here so I can get at the different pins here. And I'm going to connect the positive end. Let's use this wire here just to pin 2. You want to make sure you're getting it in the same row, and then I'm going to plug the negative end here to ground, right? And I already have my ground going up to this part of the potentiometer, so I'm just going to do that there. All right, and then we're going to add a little bit more code now to get this to work. So if I go over to here, what I'm going to do is I'm going to go back up here and define a new pin here, and I'll close out of this so it stops doing that behind the scenes. So I'll say let's define, I'll just abbreviate speaker as SPKR at pin 2, and then we'll set it up. We'll say pin mode speaker as output, right? Because we're driving out some voltage that's going to go back and forth and drive a sound through that speaker. And so what we're going to use to do that is this function here called tone. So this kind of, again, is a level of abstraction. It's abstracting away a lot of the unnecessary details, or very necessary details, but not necessary for us, right? We just want it to play a sound. And so all we need to give it is the pin number that we're talking about and the frequency that we want it to play. And so this is some frequency. It says again in tone hertz here. And so yeah, we'll just we'll use this function here. We'll tell it the pin number, and then we'll try and give it some frequency here. All right, so we're gonna go back and let's see. So wiper was, in a range of 0 to 1023. So let's just try using wiper as the value we're sending to the speaker to play a tone here. So I'm just going to add this down below here. And what I'm going to do is I'm going to comment out this line about the voltage, and then bring back this thing about the wiper so that we can see the values in the serial monitor. And then I'm going to add another line here where I call tone, and I'm going to say, okay, the pin we want is speaker, and then the frequency that we want is going to just be the value that's stored inside of wiper. And so what's going to happen is our loop's going to run over and over again really fast, right? And so every time it's going to read the new analog value, it's going to compute the voltage, which we're not using anymore, so we could comment out this line if we wanted to. So it's going to read the new value, it's going to print the value to there, and then it's going to update the tone that the speaker's playing, because it's going to continue to play that until we would call something, a function called no tone, which would make it stop. But in this case, we're just going to let it run and maybe regret it, so we'll see. But we're going to hit upload, and I'm going to flip over to here, and you'll probably be able to hear it soon. There we go. Oh, okay. So now it's running, and as I turn this, it's getting lower in frequency, and then as I turn this, it's getting higher in frequency. So if I go back here, and I go like this, all right, it's playing 680 hertz about, and now we're getting down to the 100. If I turn it really low, it just starts doing this weird clicking, and if I turn it up higher, there we go. So what I'm going to do is I'm just going to unplug this wire here and just plug it over here somewhere. It's not connected to anything, so it stops. But yeah, that's how you can play around with the tone function here. And using analog input can be an interesting way to manipulate what sounds it's playing here. I could also go in and like hard code specific values here for each tone and add delays between it to make it play specific songs, right? If I knew all the frequencies of some notes in a song, I could call tone, delay for X amount of time to play the length of that note, and then call tone again, and just keep going over and over again. So you can kind of transcribe an entire song that way if you wanted to, or you could just play around with something like analog values and write that out and see what you get. But it's pretty cool to be able to make like a little instrument with the Arduino.